What's a disaccharide? Well, it shouldn't take too much effort to understand that a disaccharide means two sugars, right? So it can't get easier than that. And this is something that we've mentioned before, but a disaccharide is basically a sugar, a monosaccharide, such as glucose, and that sugar is hooked up to another sugar that maybe could be glucose, or it could be something different. It could be an aldose hooked up with a ketose. It could be the same sugar hooked up with each other, but bottom line, it's two sugars that are hooked together by a special type of bond. And this bond that they're hooked up with, we've learned the name of that in the last video, and that's a glycosidic bond. So glycosidic linkage is what we call that. So the glycosidic linkage is right here between the two sugars. So there's a number of disaccharides that are out there that are very common. Sucrose, normal table sugar, is one of those that basically is a disaccharide. Maltose, you go through the drive-through at an ice cream restaurant and you tell them you want a chocolate malt. Well, maltose can be the sugar for that, and that's a disaccharide as well. So there's plenty of very common disaccharides. Lactose is another disaccharide. So you can look at these two sugar units that are hooked up together, and that gives you a disaccharide that we know as lactose, which is of course found in milk and dairy and cheese. So the list goes on and on and on and on. We have to talk about basically the types of bonds that these things hook up with. And we need to start looking at maybe some structures for that first. So let's start with the structure of maltose, M-A-L-T-O-S-E. If I look at the structure of maltose, this is basically going to be two rings. Okay, so there's a six-membered ring back here, and this is the anomeric carbon for that sugar. And this sugar, or this carbon, is very important because this is what's going to determine the type of glycosidic linkage that we have in the disaccharide itself. The two sugars that make maltose up is basically two glucose units. So that means I need to become familiar with glucose, and we should already know that structure. And now you see why it's so important. So I'm just going to draw the structure of glucose out here. And we said that there's 4 carbons in the center, and this is right, left, right, right. And this is our number 1 carbon, so that's here. Our number 2 carbon has the OH to the right-hand side, so that means here it points down. This next OH points up. The next OH points down. And then we have the CH2OH group that sticks out here to the side. So this is one glucose unit that makes maltose up. Now, maltose, again, is made up of 2 sugars. So that means we have 2 glucose units here. So I can, if I want, draw the other glucose, and I'll do it over here to the right-hand side. So we'll just draw the same exact structure over here. So this OH points down, and this OH points up, and this OH points down, and this is a CH2 and an OH that comes out in that direction. So here's 2 glucose units that I have drawn. Now these 2 glucose units have to hook up together. These 2 glucose units have to be basically paired up with some type of glycosidic linkage. Now this anomeric carbon has an OH on it. And that OH group is very important because we said that this is what determines alpha and betas, right? Alpha glucose and beta glucose. This is where that anomeric carbon comes into play. But it also really helps determine the type of glycosidic linkage that you have in a disaccharide on its own. So let's see what we're looking at here. If we draw the proper structure of maltose, what we need to draw is a alpha 1,4 prime glycosidic linkage. Okay, so you're probably wondering, well, how do I know that? Well, you need to know some information about the sugar first. You need some experience with the sugar. And for it to be maltose, this is the type of bond that you need to draw on a sheet of paper. So when these two molecules, when these two glucose units come together to form a disaccharide, they form maltose only when they make an alpha 1,4 prime glycosidic linkage. So the type of bonding that connects these two glucose units together is very important. Because if it's not an alpha 1,4, if it's something different, then we get a different disaccharide. Now, which one of these disaccharides do I have to remember? And the answer is you don't have to remember any of them. What I want you to focus on is the type of linkage that happens in the disaccharide. So basically what that means is that you will be given problems on a quiz or a test, and these problems are basically going to force you to look at the type of bond that connects the two monomer units together and describe that type of bond. For maltose to exist, we need an alpha 1,4 linkage. So where does the 1 and the 4 come from? Let's start there. The 1 is basically looking at this first carbon in the first sugar that I've drawn to the left-hand side. This is where my ketone or aldehyde was, right? That was the anomeric carbon. That was the carbon that was involved in the double bond. So we're going to call that number 1. Now, what about number 4? Where does the number 4 come from? And why is this little dash up here at the top? Okay, so the number 4 is basically going to be on the other sugar molecule. And this prime is letting you know that it's on the other sugar molecule. That's why they use the little dash up here at the top. They're letting you know that on the first molecule, at the first carbon, something special happens. And then on the second molecule, which is why they put the dash there, that means the second one, your other option, at the fourth carbon, we have something very special that happens there as well. So where is that fourth carbon? 1, 2, 3, and 4. So right here is carbon number 4. Remember, this was our anomeric carbon, and this anomeric carbon is where my aldehyde or ketone was, and that means that is my position number 1. So this is number 1 and number 4. Now we know that there's a linkage that has to happen here. These two things have to hook up. How do they hook up? They hook up in a alpha position. So the alpha again is very important, and if you go back, you're going to see that for the alpha to happen, well, that means that this OH group needed to be pointed down. So there's an OH group that's here. However, before these two things hook up together, we really have to take a look at this fourth carbon, and we see a hookup at that spot. Now, we've got to already remove a hydrogen from the OH group, and we also remove an OH from the other molecule. That goes and it makes water, H2O, and there is our linkage. That is our connector. So the alpha is just like before. It's telling you that at the number 1 carbon, the OH is pointed down. So you need to draw the oxygen pointed down when you connect these two monomer units together. If it was beta, it goes up, and we're going to do an example of that as well. But this is an example of a disaccharide, an alpha 1,4 prime glycosidic linkage. So number 1 carbon, number 4 carbon, we have a bond. That bond is a glycosidic linkage, and the direction is determined by the alpha or betas that go in front, and that is the sugar for maltose. So again, also known as malt sugar, 2 units of glucose joined with an alpha 1,4 bond. So stay tuned. In the next video we'll look at some other disaccharides and we'll see how they're different.